Now this is an elementary problem from a stoichiometric chapter. Question says a flash bulb used for taking photograph in poor light contains 30 ml of oxygen at 780 mm pressure and 27 degrees centigrade temperature. So what we have, let us say we have, this is a flash bulb we have. So this is my flash bulb, and this flash bulb is basically closed here. Let us make flash bulb, and this contains oxygen, and oxygen volume of oxygen is 30 ml. If I convert into liter, so this is 30 by 1000 or 30 into 10 to the power minus 3 liter. We also have pressure inside this is 780 mm pressure. So this is 780 mm pressure. Now basically we know 1 atmospheric pressure is equals to 760 mm. So we can convert this pressure in atmospheric pressure, that is pressure is equals to 780 divided by 760, and now this is unit is atmospheric pressure. Temperature is given, temperature is 27 degrees centigrade. We can calculate this temperature in Kelvin, that is 273 plus 27, that is 300 Kelvin. So this is the temperature we have. Now suppose that metal wire flashed in the valve is pure aluminum. So we have a pure aluminum wire inside this metal. So this wire contains pure aluminum wire. So flash valve contains pure aluminum wire. And it is oxidized to Al2O3. So aluminum, that is wire, reacts with oxygen and forms Al2O3. So let me first write equation, aluminum reacting with oxygen, and this is forming Al2O3. If I balance the chemical equation, so this is 2 and this is 3 by 2, and if I multiply by 2, so we have 4 aluminum and this is 3 oxygen, and this will give you 2 Al2O3. So this is the balanced chemical equation. So we have a balanced equation. Now the question says calculate the minimum of weight of aluminum wire that is used for maximum efficiency. So that is maximum efficiency will happen when all the oxygen is used. So corresponding weight of aluminum we have to find. So when we have maximum efficiency, at the maximum efficiency, all the oxygen will react with aluminum. So let us first find mole of aluminum. So we have been given volume, we have been given pressure, we have been given temperature. So let us first calculate mole of oxygen, and for that I have to assume as oxygen in this case is behaving ideally. So let us assume oxygen gas is behaving ideally. So if oxygen gas is behaving ideally, I can apply ideal gas equation. PV is equals to nRT, where R is the gas constant, and its value is 0.082, and you can find what is the unit, that is atmospheric pressure into liter and divided by number of mole and divided by Kelvin. So this is the unit for R. Let us apply PV is equals to nRT equation for oxygen. So what is the pressure we have? Pressure we have 780 divided by 760 atmospheric pressure. So 780 divided by 760 atmospheric pressure. we have volume that is 30 ml, 30 divided by 224, sorry, so this is 30 into 10 to the power minus 3, or let us say 30 divided by 1000 liter. Number of mole we have to find it out. R is the gas constant, that is 0.082, and unit is atmospheric pressure into liter divided by mole into Kelvin, and temperature is 300 Kelvin. You see here, so temperature is 300 Kelvin. So this is 300 Kelvin. So from here we can find mole, Kelvin goes, atmospheric pressure goes, liter goes. So we will have N is equals to 780 divided by 760 into 30 divided by 1000. This multiplied by basically 1 divided by 300 into 0.082. So let us do this calculation. So if I do calculation, what we will have, so let us say I have 780 multiplied by 30, and this divided by 760 multiplied by 1000 multiplied by 300 multiplied by 0.082. Now let us check the result in this case. So this comes out to be 0.00125, that is 1.25 into 10 to the power minus 3. So around this is coming out to be 1.25 into 10 to the power minus 3. So this is the mole of oxygen. So this is mole of oxygen molecule, oxygen, that is when I say oxygen, this is O2. Now I have the balanced chemical equation. So here I have balanced chemical equation. If I know mole of O2, that is 4Al plus 3O2. So we have balanced chemical equation 4Al plus 3O2, and this gives you 2Al2O3. Now mole of oxygen is known, that is 1.25 into 10 to the power minus 3. Now we have to use the regular practice. 3 mole of oxygen reacts with 4 mole of aluminum. So 3 mole of oxygen reacts with 4 mole of aluminum. So 1 mole of oxygen will react with 4 by 3 mole of aluminum. So I have 1.25 into 10 to the power minus 3. So this is 4 by 3 into 1.25 into 10 to the power minus 3 mole. So this is the mole of aluminum. So mole of aluminum is 4 by 3 of 1.25 into 10 to the power minus 3 mole. So if I know mole, we can calculate what is weight of aluminum, that is multiplied by atomic weight. So weight of aluminum, that is atomic weight is 27 gram. So 4 by 3, 1.25, 10 to the power minus 3 into 27. So this is in gram. So let us check this value using calculator. So I have, so this is 4 into 1.25 into 27, and let us say divided by 3. So this is 45 into 10 to the power minus 3 gram. So 45 into 10 to the power minus 3 gram. So this is around 0.045 gram. So 0.045 gram. So this is the weight of aluminum that basically be required. So weight of aluminum wire is 0.045 gram. This is 0.045. So I have to have one more zero. So this is the weight of aluminum. Now let us discuss this problem. So this says brass is an alloy of copper plus zinc. So if I have brass and this is made up of copper plus zinc, so this is given. A sample of brass weighing 6 gram when treated with, so we have a brass sample. So this is my sample. sample of brass, and the weight of this sample is 6 gram. Treated with excess of dilute H2SO4 gives 328 ml of dry hydrogen. So volume of hydrogen evolved. So volume of hydrogen, that is 328 ml. So if I convert into liter, so this is 328 by 1000 liter at 27 degrees centigrade. So temperature is 27 degrees centigrade, that is 27 plus 273, that is 300 Kelvin, and 760 mm pressure. So pressure is 760 divided by 760, that is 1 atmospheric pressure, because we know 1 atmospheric pressure is equals to 760 mm. So pressure can be converted into atmospheric pressure. What is the percentage of copper by the weight in the given LY? And the other thing is given, so hint, only copper react with dilute H2SO4 and produces hydrogen, whereas copper does not react. So basically where only zinc reacts with dilute H2SO4. Now this is easy to find. First let us find mole of hydrogen. So how we will find this? Using PV is equals to nRT. What is pressure? 1 atmospheric pressure. What is volume? 328 divided by 1000. And number of mole we have to find, and we know R is the gas constant. This is equals to 0.082, and the unit will be atmospheric pressure into liter divided by, this is mole into Kelvin. So this is the unit for R. So let us plug only simple numerical value. R is 0.082 and temperature is 300 Kelvin. So from here we can calculate number of mole of hydrogen, and this is equals to 328 divided by 1000, and this 1 by this will come into the denominator, that is 0.082 into 300. So let us calculate number of moles using calculator. So we will have 328, this divided by 1000 multiplied by 0.082 multiplied by 300. So this comes out to be 1.33 into 10 to the power minus 2. So this is around 1.33 into 10 to the power minus 2 mole. Now once I know the mole of this, I can calculate mole of basically zinc, because zinc reacts with H2SO4 and it forms hydrogen. So we can write equation Zn plus H2SO4, and this gives you ZnSO4 plus hydrogen gas. So once I know the mole of hydrogen, that is 1.33 into 10 to the power minus 2 mole, basically I know the mole of zinc, because 1 mole of zinc gives 1 mole of hydrogen. So mole of zinc is same as mole of hydrogen, that is 1.33 into 10 to the power minus 2 mole. So now I have mole of zinc, this is equals to 1.33 into 10 to the power minus 2 mole. We can find weight of zinc, so let us find weight of zinc. So this multiplied by molecular atomic weight, and atomic weight is given 65.4 gram per ml. So this is 1.33 into 10 to the power minus 2 into 65.4. So let us calculate this value. So 1.33 into 65.4, and this divided by 100. So 0.869. So this value comes out to be 0.869 gram. So now we can calculate weight of copper. weight of copper is, total weight is 6 gram. 6 minus 0.869 gram. So this will be, so we have 6 minus 6 minus 0.869, 5.131. So this value is 5.131 gram. So we can calculate percentage of copper. You see, question says what is the weight of percentage of copper. So percentage of copper, this is simply as weight of copper 5.13 divided by, let us take only up to 13, 3 significant figure, and divided by weight 6 into 100. So what is the value? So 5.13 divided by 6 multiplied by 100. So this comes out to be 85.5%. So around 85.5% of copper we have in this alloy. So alloy contains, alloy, that is zinc plus copper alloy, contains 85.5% of copper, and the rest is zinc. So I'm assuming there is no impurities. So assuming there is no impurity, there is no impurity, there is no any other metal is given in the alloy, no impurity, assuming there is no impurity.